G'day, in this episode of Platinum Tech, we are showing you through our new PRP RB four-wheel drive integrated dry sump kit. Just to start off, we go back to the OEM setup. It's a cast one-piece Nissan OEM item. The major issue that you have with an RB four-wheel drive system is anytime you need to do anything on the engine, anywhere in the sump, oil pump, diff, any of that stuff, you're pulling the engine out, which is already a major inconvenience. Now, other than that, the castings are a weak point, and we've got high power cars completely demolishing the diff. When that happens, obviously engine out and you're replacing the whole lot, which is fine up until a certain horsepower range, but then you start getting into the issue, you can't find them anymore. So what are you going to do? Upgrade the whole lot with a really nice, shiny, expensive billet one. 4 years ago, we started to design that. We had massive hurdles. The biggest hurdle was getting a big body Daily engineering pump, because obviously Daily's got the best and biggest name in the game. So we just have a go-to for a pump that works. Bill Daily worked with us, configured a custom setup, 5 stages, ticked all the boxes, big body pump, spins half engine rotation speed, and we also had an air separator. I'll get into that in a second. But it's a big bastard, and where do you fit it? Underneath the alternator, it hits everything. Alternators, there's bits and pieces there. So we ended up moving it underneath the pan rail, but that's well and truly after trying to get it to work underneath the air conditioning system. There's not a lot of room. The engine sits at a 9-degree angle, so you're sort of screwed there. Get rid of the air conditioning compressor, and you've got lots of people complaining because 1500 horsepower is a standard street car setup. Many designs, and finally found a spot for this huge pump to fit, still fit in the car. It's all modular, and now you can get to the billet diff to change a ratio, pull apart a destroyed diff without pulling the sump out of the car, and you can get to it easily and replace whatever you need to replace. It makes it so much easier. Some of the issues that you butt heads with when designing a factory modified sump setup is you're working out where your scavenger's got to be. Now, forget all your windage, you can't simulate any of that. You start to cut holes and slip tubes in, cut all the sump material off it. You can't put a pump where you want it to go. You definitely can't have a pump that scavenges directly bolted onto the sump. So it's more of a band-aid solution that's worked for us up until now, but it's ugly, it's expensive, and it's painful. So what you can do when you start to simulate all this stuff and get it into a CAD file is work out your 14-port scavenge system that goes underneath the drive shaft and all that sort of stuff. So let's talk about why we wanted to have the pump directly attached to the sump. It's nice and neat and compact. You don't need all of the lines and expense with all of the lines and all of the mess. There are also heaps of places for leaks and breakages and lines to get ripped off and cause you a bad day. Other than all of that, you want the oil to be as close to the pump as possible for obvious reasons. All right, let's talk specifically about the pump. So this is a custom Daily setup. Stage 1 is the actual pump. Extreme high volume pump. It spins half engine speed, gives us as much oil as we want, and you can up the pressure, go from there. Obviously, flow is more so dictated by your bearing oil clearance. And then you can up the pressure accordingly, but we didn't want to have any situations where anyone was running out of pressure or flow. So the biggest that can possibly be fitted to an aftermarket pump setup. Then we've got a turbo oil scavenge, slightly smaller than the other scavenge ports, but that will suck the oil out of the turbo, and you see drag cars potentially at the end of a straight. After racing, there's a big puff of smoke. People think it's just blown an engine. It hasn't. It's usually just too much oil in the return of the turbo line, and it pushes it up in through the cartridge and out the exhaust, and you get a puff of blue smoke. We can avoid it by sucking the guts out of that turbo. Then we've got all of the scavenge ports that go through to all of the integrated spaces in the pan. So we've got 14 scavenge points within the pan, but they all flow evenly into these 3 major ports, which are big bad boy suckers. This then pushes oil through this cavity into an oil air separator. Now, if you haven't seen how well these things work, put it this way, any run that you've got on any wet or dry system after a run, the oil is extremely aerated. If you give it another run, I'm talking a run, first, second, third, fourth, fifth, put back off and then back up and do it again. By the time you do 3 sets of those consecutive runs, I can assure you that most of your engine is full of foamy oil and it's extremely aerated. That's when you start doing bearing damage. A circuit car, for example, you might need it more than a drag car. But if you're doing highway pulls, back to back, roll racing, all that sort of stuff, you really want an oil air separator because it is the difference between having aerated oil and beautifully thick, solid, but warm oil backed up, ready to go through the system again. It's not going to cause you any issues. So that's why we've decided to go with this 5-stage, brilliant, expensive pump. They work, they don't fault, and it's got all of the boxes ticked. How this works is we have all of the oil coming through with air, aerated oil coming through this channel, and basically comes out through the guts underneath this impeller, exducer, whatever you want to call it. Now the pump's spinning, and all this is doing is throwing the oil with gravity to the outside boundary of this cylindrical surface. And all that is doing, because it's heavier, it's pushing the air in to the middle and out the vent. So you get oil out here and you get air out there. That's it. Works really well. It's simple. There's no wearing surfaces. There's no touching of anything. They're good as gold. It'll go forever. And they work. While we're talking about stages, in your conventional dry sump pump, so you've got a 4-stage whatever pump, you've got all the entries that you have to plumb in to different parts of your setup, but then you also have the exits that then need to be collated and pushed into the tank, and you're causing yourself all that hassle as well. This plumbs it all internally and it all comes out one fitting. This is just a breather. So it just simplifies all of the in and outs for the whole dry sump setup. Okay, now we've shown you through the pump side of things. I'm going to show you through the pan and how that works. We've put quite a lot of effort into getting it out through all of these different channels, which I'm going to show you through. But basically, here's your 3 main ports that I showed you matched up to the 3 main suction sides of the pump. Here we've got a turbo oil scavenge that is plumbed actually diagonally through the sump setup, and you have a fitting here right near where your turbo oil drain ends up. And then we've got a couple of spare ports, head drains or whatever. If you want to run twin turbo setup, you can utilize one or both of them. You can plumb a head drain and whatever you want to do there. It's just options. So other than that, we've got these brilliantly designed windage trays. So they're designed, most of this works under vacuum, most of the time, or it should, because your pump's sucking. We're scavenging all the oil and windage, all the oil that's getting flung off the crankshaft and any oil that lands in the sump anywhere. All of these ports then direct into basically this one area, which ends up underneath this actual drive shaft. Because we're limited with room, we wanted to keep it as compact as possible. So we're plumbing the oil underneath the drive shaft there, and there's a big slot there, which is pretty hard to machine, but we got it to work. So then that main section, you can imagine coming underneath the drive shaft, ends up on this large area to be able to get the volume of oil to work through into the center scavenge port of the pump. We have another one that wraps around here and attacks all of these. And then we have the first one here, which obviously gets the rest of the area inside the sump pan. Now, just on this, we've got our gauze mesh area here. So you want to eliminate any big chunks of metal when you blow an engine or do some sort of damage to go through the pump and ruin the really expensive pump. Obviously, having the benefits of CFD design, we're able to work out oil volume into each port, try and keep it fairly even. We're working on the windage to try and get the oil to land into these ports, and obviously surplus oil will still get drained out from the other ports at the other end of the sump. But you work out that the crankshaft's spinning that way and it's spinning most of the oil into this area. Depending on the scenario, going around corners, accelerating, all that sort of stuff, all that gets taken into, and you can model that in and CFD simulate it to make sure that you're keeping it as dry as possible. You want to make sure that your scavenge ports are at the lowest point of the sump. So however it's sitting, you want to make sure that all the oil ends up here. And there's a lot of aftermarket sump systems, especially homemade ones, that leave half a litre or a litre of oil in the bottom of the sump. You want to try and avoid that. So we've done a good job of making sure this system is as efficient as possible to make it as dry as possible, again, being the aim of a dry sump. All right, so let's talk about the front diff housing. This wasn't easy to make. Obviously, the special tooling and everything involved to get everything exactly in the right spot and machinable within a certain tolerance, not easy. But other than that, why did we go to a removable diff? Obviously you want to be able to change your ratios, have an issue, broken diff gears or whatever, you want to be able to pull it out track side and make it modular, easy to remove without pulling the engine out, and then serviceable. So given it some points of attachment with locating tabs here which take all of the torsional load. We have bits and pieces that come with this setup, and then there's some optional extras. So let me run you through all of that. We have the standard sort of drag cover, street cover. We also have a high volume cover that fits an extra litre and a bit of oil. Obviously 2 ports, one's a drain and a filler, but you can also use these for an oil cooler if you need to. The setup comes with all of the bearings and seals and bits and pieces to assemble your diff, which is pretty handy. Obviously there's a little cover here that we need just to get in and machine it all out. And here's your bearing carrier for the outside. So a little arrow points forwards, not up. So that's all the bits and pieces that we include. But optional extras, you can get a Quaife diff center, an LSD, which is a mechanical LSD. And you can also buy some aftermarket gears through us. Thank you to Neat Gearboxes. We offer sets at 354 ratio, 3.7, 389 to 1, 411 to 1, 4375, and 4.625 to 1 with matching rear sets for your R200 diff. So you've got options now, which has always been fairly limited up until now, but it obviously helps to match up the front and the rear precisely with the right gear combos, and now you can buy everything else, so you are no longer scratching around for second-hand Nissan stuff to try and make stuff work. Let's talk about what you get with the PRP dry sump kit. We start off with the dry sump pan, the flow plates, the pump itself. You have the diff basic cover or the diff hat, the diff housing itself, the bearing carrier, and the little obviously lid for the diff. All that bit comes with it. All the bolts and the O-rings and the bits and pieces come with all that. So that's that buttoned off as a one unit. But then you've got a dry sump gear for the pump. You have the mandrel that bolts to the front of your popular or a ATI balancer, and you get the right size belt. There's a couple of different belt orientations depending on whether you're running a PRP brace or a different brace or whatever, but that is basically what you get in the whole kit other than the rest of the bolts. So what can you option other than that stuff? We've got the oil pump delete. Obviously our one is a little bit different to the rest of them. This has got a pointer marker for our 36 Pro trigger. We have our TDC bolt holes here, which obviously allows you to know where top dead center is on an ATI balancer, and it fits all of our trigger kits and bits and pieces without any modification. But you can use anything for that. We also recommend that you have a head drain obviously as part of the oiling system, and you can go full tilt and include yourself a balancer. Obviously you can use any brand of balancer, but we recommend ATI. We've got the 1000 horsepower ones and our 1500 horsepower PRP ATI version. And then obviously you can throw some more sort of sprinkles on it and do the PRP ultra baffled cam covers as well. But obviously they're all options, and the sump assembly with the drive stuff is basically what you get in the kit, which absolutely gets you going. We've already got it going into a bunch of different cars. You know, there's some circuit cars, Extreme GTR, I'll end up with one eventually. We've got the SRS 33 1500 horsepower car, and obviously Jun's run it a bunch of times. We feel if it can survive a pass in Jun 2, one pass, it's pretty well set for life in any other application. I mean, it's proof enough, right? So obviously different forces and different drives to the front wheels in different applications with circuit and whatever, but 3000 horsepower so far in Jun, I think we're pretty safe, guys.